Hello. Can everybody hear me? Okay. Hi, everybody. I hope you have had a great start of your Shiny conference so far. My name is PJ Van Camp, and for the next few hours, I will be guiding you through the workshop of how to transfer your R Python, your R skills in Shiny to Python. I'm very excited to do this workshop, and I'll give you a little bit of information about me, and then I will share with you all of the materials and an outline of what we are going to do. But I will very quickly just introduce myself. So I'm PJ. I am originally from Belgium, and I started my career as an MD, but afterwards I switched to do a PhD in biomedical informatics at the University of Cincinnati in Ohio. And that is actually during my PhD where I have the very first experience with Shiny. So I have been using Shiny since 2016 because that's when I started my PhD. And ever since during my PhD and my next job, I have been using Shiny. So I am currently at Harvard University at the Department of Biomedical Informatics, where I am a lecturer in the department and also a curriculum fellow. And in this capacity, I teach the master students of biomedical informatics. And one of the things that I actually teach is a course in Shiny. So I've come a long way, and I'm now actually teaching students how to use our Shiny. But then since 2024, Python Shiny came out, and I was really curious, and I actually started to use it in my own research. I still do also educational research. In this case, I was using large language models to build some tools to assist my students in the classroom. And that was my first exposure to Python Shiny. And I actually realized how similar the conceptual framework is between R and Python. And I have spent the last few months trying to start integrating Python Shiny also into my own course. And then I thought, well, I can share this with a bigger audience as well. And so that's why I put in this proposal to show you here at the conference today how you can transfer your skills from Shiny to Python, or from R to Python. So I think one of the things I really want you to say, because one of the things that I hope most of you have is experience with R Shiny, and I really want to encourage you to be not afraid to actually go to Python, because you will see that you already know the bulk of the tricky part, and that is working with the reactivity. Like the reactivity in Shiny, that's what makes it powerful, but also tricky, but that it is almost identical in Python. And a lot of what I'm going to talk today is just some differences in syntax and giving you tips and tricks. Just as a quick reminder, as you might know, Shiny is already R Shiny is already quite a few years old now, because it was released in 2012 and Python Shiny in 2022, so a decade later. But it's only since last summer that Shiny 1.0 for Python came out, so in 2024. And although Python does have other libraries to create web apps, for example, Dash, Shiny is really a very powerful framework that I'm super happy that it's now available in Python as well. Because especially since Shiny is being maintained and created by Posit, the same company or group that actually makes R Shiny, the maintenance, the integration, and the deployment of these apps are so well done that it is very easy to deploy both an R and a Python Shiny app. So with the same type of software or like hosting platforms, you can just equally host R and Python Shiny apps. And so one of the questions that some of the people have, like, why Python? Because many people in this audience, I'm sure, will be R people, but there are some workflows that are just more geared towards Python. I think one of the big things, especially in some research, is deep learning, AI, and all of its applications now these days with large language models. Python has a lot bigger ecosystem to work with these type of libraries for machine learning and AI. R obviously has their own libraries as well, but you will see that these type of workflows now, if you want to create an app with this, that was a little bit of restriction, but now that you have Python for Shiny, then you can actually use your Python workflows that you like and immediately create them into a Shiny app. One of the things that I do want to mention is that for Python, there are actually two separate frameworks available. So you have the Shiny core syntax and the Shiny express syntax. We'll dive a bit deeper later in this workshop in how the core and the express syntax differ, but we will mostly be working with the Python core syntax. So this is because it's the most up to date, it's also the most stable, and it's very, very similar to the way our syntax is structured. So in this case, when you hear me talk about Shiny, I will mostly be talking about the core framework, but in one point of this workshop, we'll actually be working with the other one. Okay, so let's actually get started in this. So first of all, I want to share with you the materials. So I'm going to ask the people helping me out here to pin this message that I just shared. This is the GitHub repo that we will be using, or well, that you will be using in the coming hours. And I have spent quite a lot of time in the last few weeks creating a full repo that will get you started for working with this workshop. So this workshop is going to be in 4 parts. Each of these parts is going to be broken down the same way. I will teach you for about 15 minutes about a specific concept transferring from R to Python, and I will show you a demo, a live demo, and you can just follow along at that point. But then I really, because it's a workshop and I am a teacher, I want to give you the opportunity to actually practice yourself. So we'll have blocks of 20 minutes where you are just going to do self-paced exercises, and I've created all of them for you with all of the instructions. During these exercise times, that is also when you can take a quick break if you like. You can switch off your sound. I will have a timer on the screen that will count down. I will obviously be here to answer some questions, but after those 20 minutes, we'll do a quick wrap up and then we'll go into the next section. Everything that you need to know to get started is in the GitHub repo. And when I am, I'll start sharing my screen now. So in the GitHub repo, you will see that there are the 4 sections that we will talk about today. So there will be one part on how to create the UI, one on the reactivity. So how does the implementation differ between R and Python? We'll have one section on Shiny Express, just because there are 2 APIs for this library. So I want to show you how Shiny Express works in Python. And then we'll go into a little bit more advanced on okay, how do we do some really interactive tables and figures with Plotly and data table. So these 4 sections will each take about 40-45 minutes. And again, that will be broken down. Just to get you started for the setup, I've made use of, you have multiple options. The easiest option, if you don't have anything installed, if you are not super comfortable with Python, or if you don't have something like Positron or VS Code already set up, I highly recommend you to use the Shiny Live links that I created. For those of you who are not familiar with this, Shiny Live is a WebAssembly a WebAssembly platform created by Posit as well, and it allows you to run a full Shiny app inside of the browser. So you don't need a separate installation of R or Python. You don't need a server. Everything is being run inside the browser. And the nice part is that people can just create links and create these apps for you that you can immediately work with. So you will see in many places, all of this information I'm telling now is here on the setup page as well. You will see that once you go to Shiny Live, you will actually just immediately be able to start building apps in the Shiny editor. So this is a really cool way. You don't have to click this link, because you will see in every exercise that I'm making, so each part has its own dedicated README file. So for those of you who might not be able to catch everything I say, I created a README file for every single thing that goes over all of the theory, a little bit that I'm showing. Then we will go into exercise at some point, and every exercise will have instructions, but also has a Shiny Live link that once you click it, you will immediately jump to the exercise and be able to just run it. Again, we'll go over this once we are closer to the actual first exercises. But I want to say, for those of you who want to use that local, because it's obviously nice if you can run all this exercise in local, you can just clone this repo that I am providing you, and then you can just run it in your local system. The two IDEs that I would recommend using is either Positron, which is a fork of VS Code. So it's almost identical to using VS Code. I will be using Positron, which is also a bit of a shout out to the people from Posit who have been creating this wonderful IDE. But if you're used to working with VS Code, please use that one as well. It's almost identical because it's a fork of it, but it has some additional nice features that really make working with both R and Python a very good way of doing it. If you are mostly working with RStudio, it is possible to follow this workshop as well in RStudio, but it's not really built for working with Python, and you would have to use reticulate, and not all of the commands would be as easy. So I do not recommend using Positron. In that case, just use the Shiny Live links. Again, if you don't want to fiddle with setup, just use the Shiny Live links. You can also install all the packages that you need if you just look at the Pi project, or for those of you who use UV or who wants to install a virtual environment, I also have the requirements.txt file here so that you can follow along as well. But again, the only thing that you should do the important thing that you should do is once you start working with Positron or VS Code, please go to the extensions and make sure that you install the Shiny extension. Because if you have the Shiny extension installed, you will actually be able to run Shiny apps similar as you would do in RStudio right inside of Positron, and it really helps with your development. So please make sure you have the Shiny extension installed. You can have other things installed as well, like the Python debugger or whatever, but that's not really very important at the moment. But just make sure you have either VS Code or Positron, and then both of them have the Shiny extension. It's the exact same one. Make sure that is installed, and then you can set up the environment. But again, please use the Shiny Live links if you just don't want to do any setup, or you get stuck and you just want to get working with this. Okay, I really want to make sure that we can actually work and learn about this. So I'm going to stop talking about myself or about the setup. But again, during the first, I'm now going to teach you for about 15 minutes on the first section. And once we have done that, we can immediately jump into exercises. If anybody has stuck or has questions, I can answer them as well. I'm doing this at this point all by myself, so it is hard to look at the chat and do the teaching as well. So if I'm ignoring your question, please don't take that personal. I will definitely try to look at them later. But so now that we get started, I really want to start with the first part that I also always teach, and it's just the UI, because as you know, Shiny apps have a UI and a server component, and since the UI can be built independently from the server and it's a relatively easy thing to do, let's first see how similar this is between R and Python. And as a reminder, we're working with the core framework. So the syntax I'm showing you now is for the core framework in Python. So I will be coding live here, and you can just follow along. But again, for the exercises, everything will be available for you as well. Okay, so the very first thing that I want to show is that the way that one of the big difference between R and Python in general is that Python is an object-oriented language, and R is more function-oriented. So that means that in Python, things are organized into objects, functions are parts of objects, and the actual Shiny framework for Python makes use of this. So instead of just importing the whole Shiny library, we're going to import specific objects from the Python Shiny library. So we'll do here, from Shiny, we're going to import the different objects that we need, at least for now, which are the UI, the render object, and the app object. And so these are the first things that we will need. Second, for all of this is just to get started with. As you know, in from RShiny, all we need is a UI, list, and then a server function. This is identical in the Python framework, so you don't need to learn much. The only thing that you have to do is just create an UI function, and note that I'm going a UI object, and note that I'm using not the traditional UI, because UI already here is a object that you import, and if you would write your UI to the same name, you would not be able to access this object anymore. So you will see that this is just the convention, but you can call this whatever you want. So because it's object oriented, all of the UI elements are just organized under this UI object. And so the same as in Shiny for R, we're just going to create a fluid page. And one of the things that you might notice is that in Python, they have restructured the way the names are. All of the names are almost identical between R and Python, which is amazing. But the way the names are written is oftentimes flipped. So instead of fluid page, we have page_fluid. You'll see soon why they have done that, because it makes searching through with autocomplete a lot easier, because things are now structured a bit more efficiently. So within this page fluid, we can now start adding elements. And so all of the elements that you know and love in R, you are all available in Python as well. So for example, let's say that we want to create a text input. We just do UI, and then we'll do input_text. And this is exactly the same as we do in R. The first argument will be the ID, so which I'll just call txt. And then you will have a label. So we'll say here, write some text. And so you can see that this is identical to how it works in R. You have the element, you have the ID, you have the label, and then some additional arguments. Notice again that in R, you would say text input. Here you say input underscore text. Why is that actually useful? And I prefer actually this, because if you now go to input underscore, you will just see all of the inputs nicely organized for you in autocomplete, which makes it much easier to find them. And you can see all of these are ones that you might be familiar with from R. So there is no need to do anything else or to learn anything new. You just have to flip the names from action button to input action button. And so let's add something else. Let's, for example, add a select, because that's also one of the drop downs. That's also always a popular one. And in this select, we'll call the label choose. And the same for a select, for a drop down, you always have to give options. Again, the arguments are identical, but instead of providing a vector so as in R, you will just provide a list as in Python. So we'll call this option 1, and then we can make another one, option 2. And this is actually, you can also use a dictionary if you want to have a different value on the server side than you want the user to see. But at this point, I'll just keep it simple and use a list. But same for inputs, you can also add outputs. And again, all of the outputs are organized under the output first part of the tag. And so you can see, again, these are all things that you are recognizing. So we'll just use an output text for now, and we'll call this maybe out text. And so at this point, I have a input, an out. I have two inputs and an output. Now we also have to create a server function. And so again, exactly the same as in R, only the syntax is a bit different. In Python, you create functions using the def, and then we'll just use server. But then we get the same arguments: input, output, session. So again, these are all the same as in R. For now, I'll leave this empty, so I'll use the pass function. This is a way of creating an empty function in Python. And the final thing we have to do is, once we have a UI and a server, we'll just need to bind them together. And so in this case, this is by using binding everything together in a variable called app. And then we're going to use our last imported function, this app function. And in here, we'll just bind the app UI and the server together. So we'll do app UI and server. Okay, and so now we have created a skeleton for a basic Shiny app. We'll have import the object, some inputs, some output. And if I have not made any mistakes, because live coding is always very interesting, I now would run my app. And again, if you have the extension installed, you can just click the play button. I will now be able to see my Shiny app appear. There are still some of the bugs that might make things run a bit slow. So sometimes I have to click it twice to make it run, but normally this should not cause too many issues. So once you have run this, you will actually be able to see your Shiny app appearing in the in this case, in my case, in the viewer, or you can also have it. So I'll set it up for the viewer here. And so here you can see now we have our Shiny app UI up and running. And so all of the elements look exactly the same. One of the things that you can see, which is also nice, that if you have an output that has nothing assigned yet, because at this point the server function is empty, you will see this sort of waiting symbol taking place. So you know that there is at this point blank output there. So I like that. It's a nice little feature to just figure out like, oh, there is something supposed to be here. But obviously, since we don't have a server yet, we don't have created any outputs. So surprising, maybe you're surprised or not, but this is almost all you need to know to start creating UIs. And as you can see, it is near identical to how it works in R versus Python. So every type of the inputs is similar, the outputs are similar, they're just all organized underneath the UI. If you want to create some more layout, for example, let's say we want to create a sidebar, again, all of them are just in the same object. So let's say we want to create a layout sidebar. So again, you have to use layout underscore sidebar. And here in the layout sidebar, we can now add some new elements. For example, let's do one more. Let's add a button here. And I will just at this point quickly do a copy paste that makes it a little bit quicker. I will now have created a sidebar layout where I have inside, and let me organize it a little better so that it looks nicer for you. So we'll have now the sidebar layout. Inside the sidebar, we will have an action button. And actually, you don't have a panel function separately. In Python, it's just everything that's outside of the sidebar object will just be in the main panel. So if we would now re-render this, and by the way, in Positron and in if you just save and you're still running, it should automatically re-render your thing. Oh, I'm getting an error here already. Let me see for a second. Layout sidebar. Let me just quickly, whoops, fix this. Okay, so now I'm having my sidebar here, and you can see my screen is very big, made very big for you. So that's why the Shiny apps might look a bit weird, but otherwise on your screen it will be very small. But so now you can see we have the button in the sidebar and then the rest in there. The last thing I just put in is to show, if you want to show an image, for example, normally in R, you would have to use a www folder. So remember, any sort of static assets in R need to be in that folder to be working. If you want to do that in Python, you can actually choose whichever folder you want to be for the static assets, but you have to really supply that yourself. And the way you have to do this is going to the app function, and here you have an argument that will be static assets. And in here, you can provide the link. Now, in Python, it's really recommended to use a full path and not try to do relative paths, because that is actually not going to work oftentimes if you try to do it. So I like to use the convention that they recommend in from Positron as well. We're going to just use pathlib, and I'm going to create a link here to a folder that I'm going to create www. At this point, I'm going to just use one of the exercise folders, which I know contains an image. But now you can see that this image is actually present in there. So the same as in R, you don't provide the www folder or whatever folder you have in the path for the source, but you do specify it now here in the static assets. And again, I will be using this, but in Python, you can use whichever one you want. Okay, this was a very quick intro But what I now want you to do is actually get your hands on this and try starting to do it yourself. So what for the next 20 minutes, and I'm going to put a timer on, sorry, for the next 15 minutes, you're going to go through this exercise. So just go to the exercise, to the README, and I suggest that you might look at it on GitHub, because then it will be nicely rendered, or you can also just render it in here. So read the task, what you have to do. You will see an example, a screenshot of the expected output that I want you to have. But again, please use the Shiny Live link if you just immediately want to get started and not want to set anything up. So in the GitHub repo, just click this link, start doing the exercise. I'll give you 20 minutes. I do have solutions for every single exercise that we're going to do, but I really recommend you not to look at them too soon, because it might spoil a little bit of the magic of trying to figure this all by yourself. Okay, so feel free to also mute yourself. To get rid of the sound for a while, because you will see a timer on the screen, and I'm just going to put it up now. So I'll have to move this over. There we go. So in 15 minutes, we'll be back, and then we'll start wrapping up this part and going into part 2. Okay, so feel free to switch off your sound, start doing the exercises. I will stay here, obviously, and answer any questions that you have. But we'll see each other back in 15 minutes. Okay, so while everybody is doing their exercises, I will also start looking through some of the questions that people have in the chat so far. Let me just make this a little bit bigger. It's not making much of a difference. Okay. Let's see what the questions are so far. Do you add app logos just the same way as you added the image? So yeah, everything in, I'm just answering the question now asked by Eric Anku. Do you add app logos just the same way as you added the image? In Python, same as in Shiny, every static asset is put in this case, a www folder. So this also means for other files that you source in, like custom JavaScript or CSS, all of the files that need to be served to the client need to be in this folder. And then the path would be the same. Another question, and then I'll start working backwards. Do you know a way to display the output dashboard in regular Jupyter notebooks? So there are ways of using Jupyter notebooks with Shiny as well. I personally do not have much experience with it at this point, so I do not dare to give too much answer to this question. But yes, they are because Python is really Python Shiny is really still in big development. Well, they have released their version 1.0, but they keep adding new features, and definitely integration with the whole ecosystem, especially with things like Jupyter widgets, which we will explore a little bit later, is really being considered as well to make integration into all of these different environments very well. Let's see. One of the really nice things about R is that it just works. Python can be a bit more involved in terms of setting up versions, paths, virtual environments. Do you have any recommendations? So yes, I will agree. I also, because I'm by training also an R person, so don't get me wrong, I'm still team R at this point, but I also use Python a lot, again, for these specific workflows. And I think the reason that R, and again, this is more anecdotal than I'm an expert in this, but the reason that R seems to just work more is because it's more of a isolated ecosystem. It's really built for a specific audience, the data scientists, oftentimes people who know how to code, but who are not necessarily hardcore computer scientists or software engineers or very experimental, whereas Python has way more different, the ecosystem is way bigger, there's way more applications, different versions of packages because of experimental things. And so this really necessitates oftentimes more the creation of virtual environments to make sure that not any of these things is going to break. Actually, I do already have one of these things happening in here, because there is at this point an issue, for example, with the Plotly library. I'll talk about that later when we get there. But this is again something that can help. The nice thing is the positron, as people indeed just here said as well, positron is really nice for the virtual environments indeed, because not only can you just set up virtual environments quickly, but because it's really built for R and Python, if I would create an R file in here, it automatically switches environments. So it will switch between R and Python like that. And that's one of the things I really enjoy about Positron. I actually switched from RStudio now fully to Positron because I can create R files, Python files, and it will just switch between the environments and it knows which type of file I'm working in. So that's really nice. Obviously, there are still some bugs in this software, although they are being ironed out very quickly. So it is still, there might be still some features that feel a bit weird, but especially since all of the extensions from VS Code work in Python as well, in Positron as well, it really opens up a whole other additional way of customizing everything. Oh, somebody wants to see the code from the first part again. So yes, I can definitely show that. Let's see. And so again, remember everything that I say in the if you go to the README files, I'll immediately switch back. But so the README files contain a whole instructions of everything that I've said as well, right? So all of the background information, all of the code, and this is only focused on switching from R to Python, but this is all available to you as well. So yes, for Emily, so you can run both R and Python Shiny apps in Positron. You use the same buttons, you use the same thing. It just recognizes what file you are working with, and as long as you have R and Python installed, it will just switch between the two. So I'm not a representative of Posit, and it is a little bit of a learning curve if you are not used to VS Code, for example, because the UI is differently organized in Positron. But it really once you get used to it, I really enjoy it. And I think that's also why they are putting so much effort into creating this, because they know that in the future, this might be the thing to really make data science more applicable. Oh, if the question is in the same Shiny app, no. So sorry, yeah, the you can't run R and Python in the same Shiny app. No, that would be a bit tricky. I'm sorry about the about the confusion there. But there is definitely, like I said, it's hopefully I can show you today how quickly you can create one app from the other. But you still have to create a separate R and Python one. And I think that's one of the reasons that I do want more people to realize how easy it is to start building Python Shiny apps if you know R Shiny, because sometimes now we are restricted with, oh, we're doing this analysis in Python, but we only know how to make R Shiny apps. And hopefully with this, you will see that because the skills are very transferable, you don't really have to worry in trying to run maybe part of it in R and in Python and then save it for being used in R and then use a Shiny app. So you can just pick one of the systems. But yeah, you can, for development, you can use Positron for creating either of the apps, but not within the same app switch between the two types of code. Let me see if there were any other questions, because quite a few people in here. So yeah, I think so far so good. Okay, yeah. Also, I see multiple people saying the naming convention is something I would really say that as well. Like once they switch this naming convention from input underscore, it's so much nicer because everything is very organized now in these objects. Obviously, because also Python is object oriented, but that would be the same in R. I think obviously to give credit to the team, they had 10 years of experience with R Shiny before they created Python Shiny. So all of the lessons learned, they could transfer them and then create this more consistent, beautiful package. Whereas for backwards compatibility, it would be very hard to move from R and say, oh, now we're going to re-implement the way all of these things work. One of the other questions that I can see coming up here is VSleep UI elements available for Shiny for Python? So one of the things that you will notice is that some libraries are, if there is a library that is cross-platform, they oftentimes have integrations. but there might be a slightly different way of doing that. Again, I am not an expert in all of these different libraries, but for example, if it's an external library, it's not part of the core Shiny library. It really depends if somebody has made a similar package or if it is a framework that's just available across languages. For example, we'll explore the Plotly library, and Plotly is independent from R or Python. They just APIs to the same thing, and so that's why this for Shiny very easy to work in there. Are there any new import types in R that not in R? Well, I must admit, because I have been so focused on using Python in the recent, one of the things that I did see that, for example, they have a UI for a chat box. So I also have that in my, I think I have it in my README file. So if you go to the bottom of the README file, you will see input, outputs, and components. So I'm supplying you with hopefully all of the background information as well. And here in the Shiny components, you can see which all of the components are that they have in Python. And so, for example, one of the things that I did like is this chat function. It might be present in new versions of RShiny as well. I'm not entirely certain yet. It's taking a time to load because I think my computer is doing a lot of hosting at the same time. But so you can see here which of the outputs and inputs are general. But like, for example, this chat box is something that I think is really cool. That might really, for some people, create some really cool new applications. But for the rest, it's many of the things that you know and love from R. And again, they have the same naming. There's a question if there's any conditional panel. Well, actually, I have no idea. I haven't tried that one yet, but we can see. Let's see if they would have it in the UI. UI, but well, it might be panel. There we go, panel conditional. So it's in there. I'm assuming because again, they really have made a great way of transferring all of the same arguments within the functions. So almost in any case, if you know how to use this function in R, you know how to use it in Python, because inside of the function, the arguments are the same. So there is not much difference there in how it's used. It's just a little bit different syntax in setting it up. Yeah, thank you for the. Yeah, I spend a lot of time for this repo, and that's also why I am. I'm sharing this with you, and it's publicly available because I think there is. I only have this much time, obviously, to talk to you about everything that we are going to do. But I must make sure that we don't that you don't miss any other additional resources. So at the bottom of every of the README files are the links that I used, and most of them are just coming from the documentation. So they have some really nice documentation on the website. On Python, it's sometimes a little bit light if you want to go to more advanced applications, but otherwise, I think there is yeah, it's really a good thing to do. How do I add icons to action buttons? Do we have integrations with Font Awesome? I haven't. I know I have used Font Awesome in the Python version in Shiny for R a lot. I think you will just have to see if there is an argument available. But again, it also depends if the icons is integrated in the core Shiny package or not. I'm not entirely sure. I haven't used that functionality yet, but I would be surprised if it wasn't there, or if at least there wasn't a way around it. Is there an inbuilt checkbox with list items inside a dropdown in Python? I'm that one again. I am not entirely sure if there is a checklist with that, but you could definitely again, you can see on the in the documentation where they have it available. You can search for all of the different options. Oftentimes, these are part of the select, and then you have additional options to actually make them into one or the other. Just a reminder, like I'm going to wrap up in about a minute because we have to get ready for the second part of this workshop. But I hope, by the way, that people are actually doing the exercises, because hopefully that's what I hope you are doing. So let me know if you are having any big issues with that. But yeah, I really encourage you to actually try the exercises, or even if you don't have time to do them now, just do them afterwards, because it's always very easy to think like, oh yeah, I see how that works, but actually doing it yourself is really a way to get it into your fingers and to memorize it. And I've made the exercises in such a way that hopefully they're very beginner level, if you know obviously Shiny for R already, because I'm assuming most of you have intermediate or advanced knowledge. But again, I really encourage you to do the exercises. For people who already have finished some of the exercises, are there any questions that you have? Because I'm going to do a quick wrap up soon, but then we'll go into the next one. So if you have any questions about a specific exercise that you want to talk about or you want me to talk about, please put that in the chat. Then we can continue soon. Okay. I made multiple exercises. I'm not expecting you can do them all, by the way, but I always get nervous and think, oh, maybe people haven't are done very, very quickly and then they get bored. But I think it might be the reverse. Don't worry if you get stuck on just one exercise, or if you only are able to do one, because the repo is available to you anyway. And especially with the Shiny Live links, it's very quick to just have another go at it. Okay. So since we have finished this part now, I am going to start the next part. I just have to switch off my alarm. Okay. Good. So are there any other questions for this first exercise here? So quick question. So if you have the link for the app, just go to the repo. And so again, in the repo, in the repo, in every exercise in the README file, if you just scroll down, you will always see per exercise. I'm sorry. So for each exercise, if you scroll down, you will always see the link to Shiny Live. So don't worry about that. Like, you just click this link and then you'll be there. Again, I'm showing you the version inside of Positron, but just go to the GitHub, and in GitHub it's pre-rendered for you, so it looks a bit nicer to follow along. The question about using Core or Express, we actually, as you will see, module 3 will be about Shiny Express, so I will address that question once we get there. Okay, I don't see any immediate other question, so I'm going to start with the next part, because there is, I would really like to be able to keep to my schedule. I think I'm on track. So I'm going to start with part 2. And part 2 is going to be about reactivity. So obviously, everything you have done up until now is just creating UIs. And also, for any of you who have to teach new people, that's my recommendation. Start with teaching people how to create a UI, because UI is very simple to create and you don't need a server to have the UI. And so you can teach those parts independently from each other. Anyway, so now we're going to do the fun part, which is the reactivity. And I can already congratulate you, because since you know Python, since you know R Shiny, the reactivity concept is identical in Python. And that's the hard part. The thing of knowing what are reactive variables, what are reactive environments, how can I trigger an environment if something happens on the UI? Like, that's the tricky part about Shiny, to learn this reactive framework. But that framework is identical. The only difference will be the syntax. And some of the syntax might at first glance seems very different, but don't worry, it won't be that crazy. So the first thing that I want you to show you is that in Python, they have a syntax available that's called a decorator. And so a decorator is, you can see this as a sort of meta function. So I'll give you an example. I'm not going to go into too much detail about what decorators are, but imagine that I would have a function and I would call it, let's call my function test. And in this function, I would do something, it doesn't really matter. A decorator is a sort of meta function. It's a function on top of a function, and it will run whenever the function runs, but it can modify not necessarily the behavior of the function, but it can do something before and after the function runs. So imagine that I have created a decorator, and again, you don't need to know how these are created for this. That's, for example, called log. Imagine that this log decorator would say, whenever this test function is run, log when it starts running and when it ends running. The nice part is that it doesn't change anything inside of the function, but because I have created a log function that then will put timestamps, for example, in a database or in a file, I can add this syntax, this decorator, onto any function that I want to log without having to write over and over again the same code or start nesting functions within functions. And this is something that is unique to Python versus R, but the people from Shiny have taken this to the next level and have used this to really make reactive environments much more quick to write with less syntax and code. And honestly, once you get it, I find also a bit more intuitive and logical. So the way these decorators work is like underneath this reactive and the render function are quite a few of these decorators, and all we have to do is convert a regular Python function into a reactive environment. So to make this a little bit more concrete, I'll get rid of this for a second. So let's first create a new app. So I'll also close this for a second, not to confuse you. So we're going to add some new syntax, and I'll just copy paste this for now because it makes it a little bit quicker for me. So we'll have a app that has three things. It will have a numeric input, so just a number, 1, 2, 3, 4, 5. It will have an action button that you can click, and it will have a text output. So when I run this function, again, because I already have created the UI, we should at any point see the function appear, and then we can start running with this. So it's still sometimes, maybe it's just my computer, that I have to run the app multiple times before it starts rendering. But in this case, there might also be something that I just have to figure out. Okay, so in this case, you can see we have a number that we can change, and then we have a button that we can click. Okay, let's now make something that is a bit more reactive. So let's start very simple. Let's just make this output text on the server. So in R, this is already one of the big differences. If we want to assign something to an output, we use this output object, output $, and then we'll provide a specific function. In Python, you don't have to do that. You just create a function that has the name of the output. So in this case, I'm going to create a function called out, because this is the same name as here. Inside of this, I will now pass whatever I want to return. So for example, I'm going to say, in this case, return, and then I'll make a little string. I'll say and I'll now do this. I'll leave the square out for now. The number is, and then I'm going to add, this is just Python syntax, I'm going to add the input value here, there. So the input is called num. So you do input dot num. One of the things that you have to realize here is the same as in, almost the same as in R. In R, you would do input $num, but in R, you would not use the brackets behind. In Python, you do. Again, it's something I find a bit more consistent. In Python, anything that is a reactive variable or a reactive like that you can call will always have these brackets. So there is no confusion between in which cases do I use it and in which cases don't. You just always use them. This function, though, is not a reactive environment yet, because it is still an ordinary function. But let's now add one of these decorators, and we're going to say, we're going to make this an output. So we'll go render dot, and now we do text. And so this is the same as you would use in R Shiny to say, when you say output $out, and then you would use render text, and inside you would then create your output. But instead of having to have a separate function for each type of output, you now just need a decorator. And so if you use this now, you will now see that you get your number, and as soon as you update your number, it will update here as well. So just as a reminder, the name of the function needs to be the name of the output. The decorator is what in R would be the rendering function, but it has the same name, again, render.text. And you always have to make sure that you use the return argument, because in Python, in this case, if you don't use this return argument, even if there is something present, it will not be shown. So if you get no error but no output, double check if you actually have the return statement present. So this is the easiest way of creating a very quick render output. Okay, let's go to some of the other ones, because other reactive environments are the intermediate environments that not necessarily are outputs. So the ones that you might be familiar with are reactive, observe event, event reactive, and observe. So these are all these functions in RShiny that you use to capture intermediate states or create intermediate reactive variables. And the concept, again, is identical to how you would create these. So let's, for example, create a function that will calculate the square. So I'm going to create a function called square. And in here, I am going to return the square of the input. So I will do return, and then I am going to just do input num, and I'll square it. And in Python, squaring is by using this double star sign. And because I want to make this a reactive, like a reactive variable now, so the same as in R you would use reactive, I'm just going to, again, use a decorator. And instead of the render object, I'm going to use the reactive object. So I'll do reactive.calc. And so what this is going to do, this is going to say, we're going to do a reactive calculation, and it's going to return the square of the input number, and it's storing that in a variable called square. And so now we can just use this. So I can change this, and I can say the square of the number is, and I can now, instead of this, call my square. Obviously, these examples are a little bit contrived because you wouldn't have to create a separate function for it, but I just want to show you now how this works. So if we restart our application, you will now see that whenever we do it, we get the square of the number, because this is the same as a reactive. So as soon as this input changes, the value of square changes, and then we can use this. So this is the same as in R, you would have to use reactive. Sometimes you want to just observe something and do not return anything. So let's say we just want to print something to the console. We can also do that. So this is the same as using observe in R. We're going to create a function, because since this function is not returning anything, by convention, it's not necessary, but by convention, we're going to use this empty assignment to say this function is not going to return anything. And here we can just, for example, say print, and then we'll do input.num. So what we're going to do here is let's just print to the console the number that we are going to get. And instead of a reactive calc, because this is not going to calculate a value that is being returned, we're going to use reactive.effect. And so a reactive effect is not returning anything, but it is still doing something in here. So when we have this running now, you will see here in the console, we now print 2, and everything that anytime that we change anything, we'll get 3, 4, 5, but this is not returning anything. So if you want a function to return, you use reactive calc. If you want a function to not return, you use reactive.effect. And this is the same as reactive and observe in R. But again, the decorators make it really nice to just use the same syntax for creating a function. You only change the assignment of the function. We can do one more thing, and that is we can also set some limitations, as in when do we want these functions to trigger. For example, in RShiny, that would be event reactive of observe event. It's very simple to do. All we have to do is add just another decorator, and in this case, we'll do reactive, and now we do event. And so in this reactive event, we can specify which triggers should do it. So let's now say we only want to do this when we click the button. So that would now be input.button. And this is the only case in which you don't use the brackets, because when you use the brackets, you actually evaluate the function and get the value. Whereas here we don't want to get the value. Here we want to just capture the trigger. So when you use reactive variables inside of these decorators, you use them without their brackets, because otherwise you will get an error. So what we now have done is we've turned this function into one that will only update once we click. So you can see we can change this and it will still work here. But then when we click, then it only updates. And we can do the same with the observe. We can turn an observe into an observe event by just using the same syntax. And in this case now, only when we click, these things will actually happen. So as this is, I think, the trickiest part to wrap your head around in the beginning, and that is to just learn to work with these decorators. But honestly, once you know these decorators, and there's actually only 3 that you need to know, right? You need to know reactive calc if you want to return a value, reactive effect if you don't want to return a value, and then using observe, and then using reactive event if you want to isolate the inside and only have a specific trigger run. Obviously, you can specify multiple triggers in here as well. And then all of your render functions are just organized under the render object. So remember, the render object has all of the render functions. The reactive object has the calc and the event. And this syntax, again, once you get used to it, is, I find, more elegant than in R having to use this output $, specific rendering functions, and then put in the code. But the effect is exactly the same. So again, you only have to learn a little bit difference in syntax, but all of the thinking and the thinking power that goes into what type of reactive environment do I need, and how does one depend on the other, and how do inputs and outputs work, that is completely transferable. So it's exactly the same. And again, you don't need to know how these decorators are created. And the nice part is it abstracts a lot of the maybe complexity, and it makes it a bit easier to just, as the word says, decorate or adorn your code. I'm almost going to throw you into going into the second exercises, because this is most of what I wanted to show you for this part. I'll just very quickly scroll through the chat before we go into that, and then see. Okay. So again, one of the questions here, I mentioned it briefly. So why does the input button not have the brackets? That's because it's inside of a decorator. So this is the only exception. Like in every case, every reactive variable, if you would call it, if you want its value, you always use the brackets. But in this case, we don't want to get the value. We just want to see the object and monitor when the object changes. So in this case, you don't use the brackets. But you can see that's because it's inside of a decorator. So any sort of reactive variable that's inside of an actual reactive environment, inside of the function, that always has it. But if it's just being a trigger, then you don't specify it. And again, if you do use it, you don't really get an error, I think. Maybe they have changed it. It will just not work. And this is some of the confusing things that might sometimes happen. But again, in the documentation for this part, I have a whole overview of how this is working in R and Python. And I made tables to show you how these functions one-on-one transfer between, because again, it's identical, right? Like the framework is just the same. It's just, you have to just get a little bit used into working with that. Okay, I'm going to set a new timer again. This time I'll give you a bit more time, 20 minutes. And in these 20 minutes, you are going to start doing the exercises for part 2. So again, make sure that you go here to part 2. I'll have 3 exercises for you, and each of them again comes with the README file. Remember, if you're only joining later, if you just want to do the exercises without having to set up all of this, in the README file, there is always a link to the Shiny Live. And if you click it, your browser will open and you will immediately be able to start coding your Shiny app inside of the browser. So I'm going to set the timer for 20 minutes, and there we go. And let me move it. So again, if you are working on the exercises, please feel free to mute and not have to listen to me. You can just watch this screen timer go down. Once it's at 0, we'll start with part 3. Okay. I will start answering now some questions from the chat meanwhile, while people start doing the exercises. First of all, I'll try to work a bit backwards. Yes, so you're using VS Code and you can't get the app shown up. How do you have a trick? There's two things. Well, there's multiple things. First of all, you have to have, in VS Code especially, you have to have the Shiny extension installed. If you don't have the Shiny extension, you won't be able to run an app. So just easy to see it. If you hover over this, it should say run Shiny app. So if it doesn't say run Shiny app, you only see run Python file, that means that it's not working. There are multiple reasons. One can be you don't have a correct structure of a Shiny app. So the Shiny app must have the UI object, the server, and then binding it together. That's one thing. The second is that your file must be called something underscore app. It's either just called app.py, or it must be called, in this case, part2 underscore app.py. If you call it anything else, the extension doesn't recognize it. And it won't run as a Shiny app. I actually raised this issue with the people from Positron, and they are working. They are considering maybe changing this so that the extension would recognize any Shiny file, because honestly, the syntax is, I think, pretty clear. But at this point, it has to be run. Third thing is that if you even have all of this, sometimes the terminal, I have the same, sometimes the terminal itself doesn't fully load it. Then you just oftentimes have to click the button. So for example, in my case, here, if I run this Shiny app, and if it doesn't, so you will see in your terminal the things start running. It can take a while, and normally it should automatically pop up. If it doesn't pop up automatically, you just have to click the link and then choose how you want to open it. And so you can choose Viewer Pane Browser or default. I'm just going to you can then set it to whatever you want it to be. I don't know it actually by heart now, so I'm not going to change this at the moment, but that might be one of the reasons as well. Okay, more of a general question. One challenge with our Shiny is removing dynamic objects, especially with modules. Does Python also have modules, and is its handling of dynamic object improved? So yes, Python Shiny does have modules. Unfortunately, you have 3 hours with me, but modules is something I couldn't cover. I have explored it a lot because in my course, I do teach it to my students, but they do have modules available. And then I'm not entirely sure if they have already improved the handling of the dynamic objects inside of it. Again, since many of these features, like almost all of the core features, are available now in both Python and in R, that are in R are now also in Python. But since the framework is still newer, some of these things are still a bit finicky or have to be a hack. So again, I'm not entirely sure if the removing dynamically of object is there, but obviously you can find ways, right? You can remove UI, or you can create a UI output, or you can have CSS or JavaScript code that does this for you, although that's not obviously a native Shiny work. One of the things I can say that is not available because it's an external library, I really like to use Shiny.js in R because it really helps with like disabling, enabling elements, removing them easily. I really like to use that functionality, but it's an external library that doesn't have an immediate equivalent. I'm really hoping that somebody in the community at some point will come out with the Shiny.js package for Python, or maybe that the people at Posit include this. But yeah, I don't have an exact answer for that. How do you do troubleshooting with the browser? So it is one of the things also that's still a little bit tricky, but it's mostly because I don't have that much experience with it. once you have your Shiny app up and running, you can choose here the debug Shiny app. So if you then have used the browser element somewhere, it will run. So if you just run the app regularly, it won't work. But if you use the debug Shiny app, it should start debugging your app, and then you can walk through your app line by line. You might also have to have the Python debugger installed for VS Code. I'm not entirely sure. It's been a while since I've done that. But yeah, and you should also be able to just put in your known exclamation points, or like your breakpoints here, and then if you run your Shiny app in debug mode, it will stop at a breakpoint. I do find the debugging still sometimes a little bit tricky. I have had some issues with it, but this is more positron based, and they're really improving positron very, very quickly. So I wouldn't worry too much that like in no time it will be identical. But I think it's already, yeah, it should already be the same. Okay, let me keep scrolling for questions. Is this work if you put the reactive calc after the reactive event? Yes. So the order of these, the order of them don't matter. I just usually do that for myself. Put the reactive calc or effect first, and then the event below, because it reads, for me at least, nicer. But no, the order doesn't matter at all. And that's also a nice part I find about these decorators, is you just add another functionality or constraint or whatever this does to your existing function without having to really change the syntax of the function itself, and it makes it cleaner to read, in my opinion. Let's see. It's interesting to see how they combine the mindsets of Shiny and Python for the example with the decorators. Yes, I had learned about decorators in Python very vaguely, but I never really understood them. But then now with this, I think it's a brilliant application of it, because it really helps to abstract this whole reactivity from it, but make it as an end user without knowing what these decorators are. Very easy to just create them. This all you do is literally decorate or adorn these functions with it, and you suddenly have functions. By the way, you can still create, same as in R, right, regular functions as well. And if they don't have this tag, and you try to use a reactive variable in that, you will get the dreaded message that says you try to do something outside of a reactive environment. So it's not foolproof, but I feel it makes it a bit easier to distinguish between reactive functions and environments and non-reactive environments. Keep scrolling. Let's see. There is another question: can we make the output number displayed in bold? So again, I'm giving you very simple things, but in this case, if you're using a rendered text, you're using the default text. But you can also, for example, use render UI, and then you can easily make this into an HTML tag. It's actually one of the things I didn't really talk about much in the UI. I think I skipped over that part, unfortunately. That all of the tags are available as well. So if you would change this from an output text to an output UI, you can now do render.ui, and I can now put here my UI. Let's just do the bold tag. But you could also use HTML, the HTML tag. And then if I run it, I should be able to. Did I make an error here at this point? I don't think so. Oh, sorry. Let's just use HTML for this example. So I can use the HTML tag, and in here I can just create any sort of HTML tag. So I can use here HTML. And now if I click it, you will see I have the square of in bold. So all of the tags, maybe just the B has maybe a little bit of a different thing, but under the UI, you will see all of your HTML tags. You will see A, you will see break. So any HTML tag that you have, you can immediately use there as well. And then just use a render UI instead of a plain text one if you want to really make it prettier. And you will see in the exercises, I often use render UI to make things look a bit nicer. Okay. I think for now, I have answered almost. Oh, is there a difference between the reactive calc and reactive calc? When I'm using in my dev, I don't see a difference, but I want to confirm. Um, I am not entirely sure for that question. I've seen that as well, but you should always use the small one. So reactive dot event effect calc with the small c and not with the capital C. If they do both work, that might be fine, but I'm just basing myself on all of the documentation. I think there might be different that you can create specific additional objects or maybe do additional things with it. But this is, yeah, I am not entirely sure about that. But if they do work the same, great, but I would really recommend using always the one with the lowercase version here. Mm, okay, good. So far, no new questions, so I'll just have a sip of water meanwhile. There's a question about how do I get the UV environment set up. So UV is it's a really cool new Python environment manager that I like to use because it is very quick to set up dedicated environments very easily and with way less prone to errors. Set up all of your files. So you have to install UV separate. So it's Astral UV. I don't think I have provided the the actual reference in there, but the this. So Astral UV, this is the new Python project and package manager. It's open source. It is wonderful. It is extremely fast. Like it is insane how quickly you can set up environments, and it does everything. It will even you can even specify which version of Python and how you want to do things. And then once you have UV, you can create these log files that will very easily make you synchronize environments. So if you have UV installed and you use my repo, you can just use UV sync and it will just set everything up in one go. If you just use regular Python environments, you would have to use the requirements.txt file to then start installing the packages. But I actually generated this file using UV, and also UV will manage your Py project.toml and everything else. This is more of a personal choice, so I don't want to say that this is the way to go. Don't get me wrong. So that's not what this workshop is about. So don't take this as this is how you should set up your environments. It's just a very nice package manager. Somebody says here, I keep getting prompted to install all the packages, including the date-util that pip didn't recognize as a separate module. I don't know if this was I'm assuming this is in the actual IDE. So it depends on how you install things. Like if you use pip install, you only should be needed to install these libraries, and all of the rest the dependencies will all be installed automatically once you do it with it. If you're talking about Shiny Live, in Shiny Live, I do provide a README, a requirements.txt file, so it will install all of the libraries as well. Because again, Shiny Live is all within the browser, so it needs to pull these packages and be able to run them in the browser as well. So every time you restart, it will, although they are cached, but it will reinstall them to be able to run the app. Someone says, I can't seem to get the image tag work in exercise 1. So yes, this is one of the things that is a bit confusing. So the image tag, the way that it works is, again, you have to have the static assets. So let me get rid of this a bit. you have to have this static assets folder defined, and you have to give an absolute path. Like in Python, it really wants you to not just give a relative path, but an absolute path. In this case, this is just some syntax that I use from the path library. You could provide the whole path on your system, but it's never good to actually hard code absolute paths because it's less transferable. So just make sure that you use this, or if you prefer to use the OS library, you can also do os.path and then create the path that way. But just make sure it is a fully, it's a it is a not a relative path, but it's an absolute path. And as long as it goes to a specific folder, everything in that folder becomes available. But remember, don't use the folder actually in the source name, because this is the only folder that will be publicly accessible. And so you don't need to specify that. Okay, I'm slowly going to start getting ready for my next section, but we still have we still have 4 minutes, so feel free to keep asking me questions meanwhile. Does the UV log file work with Posit Publisher extension? No, it doesn't. So if you want to use, well, at least at this point, so if you want to use at least I have published quite a few Shiny apps using Posit Connect, and Posit Connect still expects a requirement.txt file, but there is a command that in UV where you can generate the txt file from the log file. So no, if you have a requirement.txt, you need to have a requirement.txt file to publish Shiny apps, at least at this point, because again, the UV framework is independent from Python or Shiny. So as long as they don't implement that, yeah. So if you have, oh, there's still a question about the JPEG. So yeah, in this case for JPEGs, you can just provide the URL, right? So if you have, you don't need a static assets if the asset is not local. So static assets is local. So if this is an image from the web, just provide the URL here. It needs to be the full URL. So with HTTPS and then the full path. But then you will see it as well. So the static assets folder is only for locally sourced images that need to be available in your app. If your resource is from the internet, you will see in many of the exercises, I provide CSV files or images that are just coming from the web. Then in that case, you just need to provide the URL. That's how just regular HTML works. Again, I might have, although I went through all of the exercises, so there shouldn't be any, hopefully, any bugs. But if you find a bug, feel free to let me know. And best way would be to actually open a GitHub issue, because obviously this repo can only become better if more people use it and test it. And I don't think I've ever had that many testers for any of my projects, because I now have, there's over 200 people here at the moment. So I don't think you were all actually maybe doing the exercises, but still. We're almost going to get started with the next section. So people are hopefully wrapping up the exercises. A lot of questions about UV here. Is a UV framework much different from Pi environment? Again, I think it's just it's a little bit different of a mindset with UV. They really just want to make sure that it's also written in Rust. It's very, very fast. And I think it's more of a like one stop to set up a whole Python project and environment. Again, I only started using this 6 months ago or something. So it's not really part of this workshop. So I'm careful with telling you how this all exactly works, but I'm still figuring things out as I go as well. But I agree that like setting up a good Python environment, and that's why I think I am so happy that the Shiny Live exists, because all of you now do not have to worry at all about any of the exercises not working. You can just click the Shiny Live link and just do it in your browser. And I think that is one, I didn't realize how powerful this was until I started making this workshop, that now you can all start. You don't have the excuses like, oh, my computer isn't working or the setup isn't working. So there's one question: can we use pandas as regular? Like, I also sorted the years in the year column. Yeah, I mean, I am just providing you with all of the functionality. If it's not Shiny functionality, I have given you a example of how you could do it in Python, because many of you might not be very versatile in Python. So I don't want you to create or filter pandas data frames or generate images. That's all done for you. So I will always provide the basic Python code. You just have to make it reactive. Okay, so we are going to start wrapping up this part, because we need to start getting ready for the next one. Okay, there is one question. Okay, I'm not understanding something. An image function will return image URL to a JPEG, just so the URL, not the rendered image. Yeah, you have to make sure that you use source, right? You don't make sure that you actually use the source argument, because it's not the first argument in the function. Because this is translated to HTML. So you don't need an add render image if you are doing this just hard coded in the UI, or if you're returning a reactive UI. There is also an add render image, but that's a separate functionality. But this is more my personal idiosyncrasy. Maybe I just usually return an HTML output, a UI output, and then I just use the image tag. But on the website, on the documentation, you can see that there is an example. There are examples on how to use the render image tag. I don't know exactly the difference between them, but I think this might be more for like really local images, or if there are more complex things. But I usually use render UI if I'm just using a static image, and if it's a plot or whatever, then you have another function, and it's a plotting function. Okay. I am going to get started with the next section, just to make sure we are moving. Let me actually check my own agenda to see how well I'm doing on time. It's now 1:30. Okay, so I'm ahead of schedule, it seems. Oh, that's good. Wow, I didn't expect that I would actually be ahead of schedule. So that's good to know. That means I'll actually have some more options to explore some of the things in the end I was going to show you more quickly. So that's good. I'm going to move to the next section. Again, if you have any questions, please feel free to put them into the chat, but I will mostly answer them during the next break, because the next exercise part, because it's very hard to monitor both at the same time. So for all of you who want to follow along now, so we're now going to go into part 3. So everything you need to know will be in the README of part 3. But again, I will live code for you. And in this section, we're going to explore briefly the Shiny Express framework. So everything we have been talking about now is the Shiny core framework. Why did I spend so much time, and why will I be also spending the rest of the time on the Shiny core framework? It's because this is the framework that originally was created. It's the best maintained. It has all of the features. It's the most stable, and especially for this audience, the core framework is in syntax near identical to R. Well, in syntax, not in syntax, but like in layout, in average, the way you construct things. But the people at Posit, they are very creative, and they came up with an additional framework, which is called Shiny Express. And so Shiny Express, as the name suggests, is a way to very, very quickly create an application, a Shiny app, from a Python script. So with just a few decorators and a little bit of syntax, you can create an ordinary Python script. You can convert it into a Shiny app. And this has many different use cases. One of them is quick prototyping. So if you want to just really create a very quick idea of an app, you can use the Express syntax, and we'll show in a minute what the differences are. But it's also very good if you have, for example, a long script. If you're a data scientist and you're working on something and you find yourself looping over a specific part of your code to say, if I change this variable, I want to look at the output of this figure and see how certain filtering or analysis or change of parameters will change it. Instead of having to create a whole app and organize things in UI and server and break everything down, with Shiny Express, you can just slap on some decorators and some UI right in the middle of just plain Python code and turn that part into a Shiny app. And that's a really cool thing that you can use. The first thing to notice, and that's why I'm starting from blank here, is Shiny Express is a different API. So it means it's a different part of the Shiny library. So instead of doing importing from Shiny, we're doing from Shiny.express. And so now we're going to import the same type of things, but now we're going to do them from Express. So we're going to do input UI render. And so these are the things that we will, these are the things that we will now start. Oh, I forgot to make this here. So remember, if we're going to start working with Shiny Express, we need to use the Shiny Express API. And although it looks the same, we're also having here the UI and the render object. If you accidentally import them from the core library, which is just Shiny without the .express, this whatever I'm going to show is not working. Input needs to be done separately because we won't actually have a UI and a server anymore. So this object has to be. This is going to keep track of all of the inputs. So let me show you a little bit how the Shiny Express library can work. So let's say that I want to create a UI element. I don't have in Shiny Express a UI function or a UI object or a server function. You just write it wherever in your code that you want. So let's, for example, this case, we haven't done a checkbox yet. So we'll do input dot, we'll do UI dot input checkbox, and we'll create a checkbox here, and I'll call it just check. Okay, you can see at this point I have not created anything else, but because I'm in the Shiny Express framework now, if I now just render this, I should get just a checkbox on my screen. And so there you go, here it is. So I just have a checkbox. And it was just because I just wrote it down in this code, and there can be regular Python code before this or after this. It will just render it from top to bottom. Let's do something else. Let's, for example, say we want to also create an action button. So I will do UI input action button, and I'll call this button, and then click. Again, don't use commas here because we're not generating a list. We're just literally generating objects as we go, or elements as we go. And you can see that the click element is now put below this one. So in Shiny Express, wherever you put your input, and there can be a lot of other Python code in between here, it will just read it once from top to bottom, and it will order the elements from top to bottom as well, because there is no separate UI function to put things into order. Although you can do it, and I'll show you in a second how. Another thing is, like, let's say we want to add an output. There is no dedicated output function or output placeholder. So in regular Shiny, you would use UI.output and then put something, but you can see there is no autocomplete because there is no placeholder. You just immediately put the reactive environment that creates the output wherever it needs to be. So let's say we want to create an output here, and let's say we want to create it, let's do it just here. And we just going to create our function, and we call an output function called out. And let's put in some text. I'm just going to copy paste this. So this is just going to say if this thing is checked, we'll return checked, otherwise we'll return not checked. And we need to now add a render function here. So this is again our decorator, the same as in the core framework, and we'll do render.text. So we created a function, but in this case, this out is not linking to anything. It is just going to be rendered exactly where it has been placed. So now you can see here, the output is put in between the checkbox and the action button. And whenever I change my input, my output will change. So you can see why this is called the Express framework, because you don't really have to create many new nested elements. You just put the function wherever you want it to be, and then it renders. And if all the code above or below or in between is not reactive, it's just not going to be part of your app. So this could be nice. That imagine you would have, for example, in a long script here, an image that you are trying to, or a piece of an analysis that you're trying to do. You can very quickly just create an input instead of having to reassign your variable manually. Slap on the output in a function, and you can immediately start testing that part of your code. So it is, I think, also for debugging, data exploration, prototyping, it's a very, very quick way of doing this. We can, however, can create the more layout. So let's say, for example, we do want to create a sidebar. We can do that. But the difference is, and this is a piece of syntax that's different between core and the Express, is that since we don't have a fluid page at this point, or an object that gets everything, how can we now decide which part, for example, in the sidebar layout should go in the sidebar, which part should actually go into the main? So what we're using now here is not decorators, but it's another concept that is unique, or that is different from R, and that is our context managers. So the context managers always start with this with statement. If you are a bit familiar with Python, you know that this is oftentimes used for like reading and writing files or getting connections to databases. So this will create an environment, so this with, and everything underneath that, like in a function, as soon as that function has been run, it is out of scope and everything is automatically closed. So this is oftentimes used for reading files, and as soon as a file has been read, this is over. Shiny Express makes use of these context managers to actually create layout. So let's do that. Let's say with UI.sidebar. So again, we're immediately creating the sidebar. We're not creating a sidebar layout because that is not an element available. We're just only creating the sidebar. And now anything that goes under here will become part of the sidebar. So let's move this checkbox into this sidebar. And so now if we render this, hopefully if everything goes correct, we should now get a sidebar layout. There you go. And this checkbox now has become in the sidebar. But because this output function is not anymore inside of the scope of this width, so not inside of this context, it is separate. But we can still put it in there. So just by putting here a tab, we now move this output function underneath the sidebar, and now the action button is still there. So if we save this, we will see that now things have changed, and now our output is again in the sidebar, and our button is still in the main panel. So this is how you can create layouts, and oftentimes even a little bit more complex layouts, using these context managers instead of creating all of it in one single nested UI function or UI list. So the biggest difference between Shiny, Core, and Express is that in Express, you don't have a dedicated server, you don't have a dedicated UI, but you use these context managers to put things in specific places in the UI, and the rest is just organized from top to bottom. So the thing that comes first is the thing that's rendered on top, and the things that come later are the things that are rendered below. Rendering functions do not have dedicated UI placeholders. They're just being rendered wherever they're being declared. You can also use all of your other reactive environments. So if I want to, for example, create a reactive effect, I don't know if it's confusing. I'm sure it's intentional. This actually still is part of the core library. So you have to import that separately. So you have to say from Shiny import, and now we're importing the reactive object. And now we can actually create our reactive effects. So let's, for example, say I just want to create an observe, and I would want to say here, whenever I click my button, I just want to print that. And again, these can go anywhere. It doesn't matter because they are just reactive environments. And now you will see whenever I click my button here in my console, you will see the number appear because this one gets triggered. So just as a quick summary, in Shiny Express, very good for quick prototyping, for just creating parts of an existing script, turning it into a reactive one by importing from the Express library, using context managers if you want to really create some layouts, but otherwise you just define UI elements wherever you want, and rendering functions will be rendered wherever they are being declared, and you can use all of the other reactive functionality as well. Okay, so for the next 20 minutes, again, you can work on 2 exercises for using this for the Express. The first exercise will really be just simple, turning an existing script into more of a reactive script. The second one, it's a bit more advanced, but that's just to really start to work a bit with these context managers. So I'm making you nest these context managers to figure out how you could create complex layouts with Shiny Express. So don't think that Shiny Express is necessarily extremely simple. It just has some limited sometimes functionality, or like it's not built to create very complicated and big Shiny apps. Not all functionality is available in the Express framework, but it is being added very quickly. For example, until very recent, it wasn't possible to use any modules, but now they have added modules. They have found a way to create modules using this syntax, just so you know. Okay, so I'll set this to 20 minutes, and then please go to part 3 exercises, or continue with the exercise you've been working on, and then I will start answering questions again. But please try to actually do the exercises, because I think it's very important to try to do those. My timer is already running, but I am just going to move it over. Okay. Good. And I'll switch to the question. So again, feel free to mute me, go do your exercises, and I'll see you back soon. I'm just going to take a sip of water, and then I'll start answering questions. Okay, so I'll start again from back to top, but I think I have enough time to answer all of the questions. First one, when you say Shiny Express is good for prototyping, does it suggest it does not scale up or that it's not robust? I will just be paraphrasing the people, the website now, like from Posit, where they explain Shiny Express. They say that it's exactly the same framework. So it is not that this is in any ways slower or faster. It uses the same behind the scenes framework to render everything. So when it comes to scale, I don't think that is necessarily the issue. The thing does become, though, complexity. And that is where they, and also from my experience, suggest that if you know that you're really creating a very complex app, or if you started using Shiny Express, but then you start adding more and more functionality, it might be good to transfer to the core framework, because the fact that you are organizing UI in one place, and that your server function has these dedicated pieces, it's easier to make things a bit more concrete, and to really organize your code better. Plus, if any of the new features are coming out, they're first coming out in the core framework before in the Express. And Express only has been here now for a year, I think. So there are still a lot more potential bugs in this code, whereas the core syntax has been being built for years now. So I would really, if you're really worried about like production quality, but also scale as in complexity of the code, definitely go for the core framework. But again, if you just want to really quickly build something and you know the Express syntax, it can save you a lot of time to not have to do all of this boilerplate code, or especially with existing scripts, start reorganizing things as in what goes into the server, what goes into the UI, how I'm going to do this. So yeah, the oh, there is already a question. The NAS exercise you run exercise 1 is a 404. Aha, that's not good. So I will actually share with you the let me double check. Crap, and I checked all of them, but okay, I still get it when I click it in my link. Okay, I'll share the Shiny. Okay, can you hear me again? Sorry, I accidentally closed my browser. In the small panic of trying to share the Shiny link, I accidentally closed. So you can hear me, right? Yes, okay, good. I'm just setting my things up here again before I mess everything else up. And then I'll go again into answering the questions. I mean, it was already going too well. I had no hiccups so far, so there was bound to be something going wrong at some point. I will also share with you the Shiny Live link. So this is going to be a very long link because I actually use the URL. I'm actually shortening this URL, so I don't know if I can share it here. No, it's too long. It doesn't allow me to. Okay. Let me figure this out. Just a second. I will. Okay. Can you let me know if this link works? Oh, is it the NASA data link itself that's broken? Let me check that. Feel free to obviously do exercise 2, right? So not. I checked all the things yesterday, but maybe at NASA, well, at the governmental website, they have stopped hosting that file. Yeah, it doesn't seem at this point. I also get a 404. That's too bad. So yeah, for now, I think if the oh, that's sad. If that doesn't work, you just should focus on exercise. So I'll try to for a couple of minutes see. Oh, by the way, if you want to expand the link, it's a very long link, but the actual Shiny app link works. So if you go to Shiny Lab, you will still be able to use it. The problem is that I'm downloading a data set through a URL, but that one is not, it seems to be not available anymore at the moment. So I will double check. Let me see. So yeah, I think if you the data set that you need is this one. So if you actually go to the if you scroll down in the exercise and you go here to the references to the data set, you should get here. And so it's this CSV file that you need. So hopefully, well, okay, no, never mind. If you click on downloading it, it's no longer available. So I'm sorry for that. I don't think I can help. I checked it yesterday, but maybe the government has changed their accessibility from public data sets. So I'm sorry for that one, but please feel free to then work on the exercise too. But then I'll wrap this section up a bit earlier so that we can actually work on the other parts a bit more. I'll see if I can find you. Meanwhile, by the way, I'll first start answering some questions. If somebody finds the data set, that would be great. But again, at this point, it's not that important. You have plenty of other exercises to work on as well. Okay, let's see. Okay, are there any resources and experience on modules within Shiny Express? Yes, so there is, since it's not very recent, but they have implemented modules for Shiny Express as well. Again, on the website, on the documentation for Shiny, they will actually oftentimes show you in the examples, you can click Shiny Core or Shiny Express and you will see how they implement. So if you go to the posits, well, I can show you here as well. So if I go to Shiny for Python here, in documentation, you will see Shiny Express, Shiny Core, but it's mostly if you go to the different things. For example, if you go to templates, you can here see all of the different examples. But if I, for example, would say modules, oops, well, no, this one isn't working either. You will often get the example code. I'm just trying to find where the actual, it's been a while since oh, no, this is Shiny Express. Oh, here it is. So here, if you go to modules to learn Shiny modules, you'll see they will always give you Express or core syntax. So you can just switch between them. So in this case, for modules, if you want to learn how to actually use them, you can just switch and you will be seeing both of the examples. Again, I think if your app is already in the stage where it needs modules, I would argue that this becomes already a more complex app. And at this point, I would recommend sticking to the core framework and not using the Python, not the other one. Okay, let me see if there's other questions. By the way, I will find a way to fix this dataset. And so since you all have the link to the repo, if you feel excited about this and you do want to try, hopefully, if I either today or otherwise later this week, check the exercise again, and I hopefully will have found the original dataset and will actually commit it to the repo so you can use it locally instead of using the URL. Another question, Shiny Express does not have reactive, so it does have it, but it actually just is being used from the main library. So in Shiny Express, you do have all of the reactives, but you just import this functionality from the core library. So they don't have their separate, because the way it works is identical. The reason you need different objects for the input is because in the normal Shiny app, this would error out because you can't put a UI outside of an app element. And as you can see as well, there is no app last line that binds everything together, because so that is why these objects have to have their separate object, but the reactive functionality is identical, so that's why it's imported from the main library. I think I've answered most of the, let's see. Okay, by the way, just so you know, maybe for exercise 1 as well, as a reminder, I don't want you to actually use it to cheat, right? But the all of the solutions are available, right? So if there is something you do want to, if you're really, really stuck, because obviously I can't help 200 people at the same time, feel free to look at any of the solutions and they should all work. They do, if there are any type of local files in there, they are referenced from the folder where they were originally in. So sometimes if an image doesn't render or something, that is because the exercise needs to be in the, you need to copy paste it into where the original location is. But you should be able to paste these solutions also in Shiny Live and immediately see the results as well, as long as you have everything set up. But again, I recommend not looking at the solutions until you're really stuck or you're finished and you want to check with what I did. Okay, do you have any practical experience moving from Shiny Express to core? What advice would you give? Yes. When I started my Python journey, I accidentally learned the Express syntax first because I didn't know there was a difference. And it's also actually on the website, the default of the two. So if you see the code, it shows Express first and then core. You have to click on core. And I didn't know what the difference was. That's why I'm spending some time on it now. And it is a little bit of a pain because, again, if you want to switch from Express to core, you have to start organizing all of your functions into a UI and then pass out your server and make sure how all of the rest works. So I would really recommend use it for prototyping. As soon as you feel that you're getting somewhere and you want to continue, switch to the core syntax. Or if you know it's going to be a big app, just use the core from the start. Again, I would recommend, from my experience, if it's more for like exploration, the app is temporary, it's only for you yourself, it's not going to be something to be published, you can use the Express. Or if you want to just quickly whip up an app that you can share with somebody, you can also use that one. Okay, let's see other questions. But due to the Shiny Express, we need to write the select below the vehicle tabs. I was very confused why it's giving an error. So yeah, again, that's why I don't want to confuse it too much, because if you are used to R, and that's why most of you are taking this workshop, the core syntax is way more familiar. The Express syntax sometimes seems a bit weird, especially since you have to use these specific context managers. But again, definitely make sure they have you imported from the right library, otherwise you will get errors whatever you do. And also make sure that you don't use any template code from an Express app, because if from a core app, because if you try to put the app binder in here in the end or something, it will also go wrong. And again, exercise that I'm giving you, so the only one at this point that you can do, exercise 2, is a bit of a trickier one, because I want to show you that you can create complex layouts with or more complicated layouts as well, but you need to wrap your head around it a little bit more. But again, if you don't really need to use Express, I just want you to know it's an option. I'm just going to check how I'm doing on time. Okay, good. Okay, so hopefully everybody is still with me, and apologies again for the broken exercise. It literally must have changed in the last day or two. So, and again, feel free, make sure to check this exercise again. Hopefully by tonight, definitely by the end of the week, and I will have updated the repo so that you can try the exercise after all, because it was actually a nice, a fun little data set to explore. Okay, let's see if there are any more questions. I see one question. I used your codes as shown on the screen, right? But now my app still isn't updated. My app still shows the part 2. So again, make sure that if you are running in Positron or in any other IDE locally, that you make sure that your Shiny apps are actually running properly, right? So you have to look at the terminal, and sometimes you might have to click the actual link to open up the app in your terminal. But again, I don't want you to get stuck on this now, so use the Shiny Live links if possible. But otherwise, you should be fine. Okay. I will definitely have more time for some questions in the very end, but let me now go into the last of the sections that I want to teach you in SparkSoft. For this last hour, we're going to do one more module, and then we're going to start wrapping up the whole thing, and then you will have some more time to actually work on the exercises as well. So the last part that I want to show you now is working with reactive interactive tables and Plotly, and so interactive images. So I think one of the most powerful things about Shiny, I personally find, is that it has some very useful techniques for you to be able to work with interactive tables and images. And why is that useful? Because if you have a interactive table, your user can select specific rows in the table and drill down in the data. The same with interactive plots. If you have a plot where the user can either select specific points or click on a point or zoom in, and you can capture this information, you can actually do a lot of additional analysis, and it allows a sort of visual exploration of your data versus having to create drop-down menus or other things that you have to type in. And Shiny has multiple different ways of connecting to interactive plots and tables. The two that we will explore are also the two that are available in Python, and that's why, in R Shiny, and that's why I wanted to show them, which are data tables, which I think many of you are familiar with, and also Plotly for plotting. I will go into Plotly a bit later, but I'm going to start with the data tables one, because that is not only the easiest, but it's also the one that is actually natively available in Python already. So for data tables, it's part of the Shiny library, so you don't need to import anything else. On the other hand, data tables are in Python almost always used with something like pandas or any other of the popular libraries that can generate data frames. So that is something we do have to load, because this library is not available by default in Python. So again, remember, we're back into the core syntax now. So it's over for the Express syntax. I'm just showing you core again. I've created here just again the skeleton of an app. So I have created a very simple data frame. So this is literally just 2 columns, 3 rows. I'll show you a little bit of data. So just 1, 2, 3, and ABC. I didn't want to make it too confusing for this because again, this is not about learning to work with data frames. It's about how to render and then interactively work with them. Remember as well, same as for our Shiny, the scoping rules for the core app are exactly the same. If something is defined outside of the server function, it means it's only needed to be initialized once, and then every application that every instance of your Shiny app that is running automatically has access to this object, and so you only need to have memory for this object once because it's just they can just read from it, and there is no need to redo the prep in every single instance. However, if you would have put this code inside of the server function, that would mean this data frame would be created every single time somebody logs on to the app. And also, if this would take a lot of time or memory, that would multiply between all of the instances. So that's why I'm putting this outside. Obviously, this is so tiny that it wouldn't matter at all, but I just thought I'd throw that in. Okay, so at this point, we are going to try to create a data frame. So the first thing that we need to do is actually put a placeholder here where we can put our table. So again, this is going to be a UI element, and we're going to do output, and it's called output data frame. So interestingly, this is a little bit different from R. In R, you do data table output, but in Python, they have chosen to use data frame, maybe because it can do multiple types of libraries that have data frames. So I think they're just choosing the more generic output, but this might be a bit confusing. This output underscore data underscore frame is exactly the same as in R output, the data table output. In R, there is a separate package, the DT package, the data table package, which also has a binding for Shiny. But in Python, you don't really have any distinction almost between these, so there is no separate library. You can just do everything within the core library as well. So okay, let's just say we're going to have this data frame, and now let's just render this on the server. So we'll create a new function, and again, same as we've always done, the name of the function will be the name of the output element, and in here we're going to put our data frame. So what we're going to return our data frame, which is called info. But one of the things we have to do is at this point, this is a pandas data frame, and we want to create a data table from it. So one of the things we have to do here is from the render function, and this is one of the only cases you need to do that, we're going to have the data table object. And see, this is a case where you do have the capital letters, because this is actually a function. This is not a decorator. This is a function from the render package that will turn this pandas data frame into a rendered data table. It would render also if you do it like this, but now we can, and we'll show that in a second, we can set some additional options for this data table. All we have to do now is add our decorator. So we're going to add our render dot data frame. And so now we should have everything ready to create our app that has a data table as a default rendering. So my Shiny app is starting up here, so it hopefully will go quickly. There we go. Oops. I've got an error. Let me double check. What have I done wrong? Oh, I have put my decorator in the wrong place. That's the thing with live coding. It's always a challenge to make sure you don't make any impression. Okay, here we go. So we now have our data table. It doesn't maybe look like an interactive table, but actually when you click the columns, you can start sorting them. That's one of the functions that is automatically provided in the data table function. So this is not just a static HTML element, this is actually an interactive element that has a JavaScript library behind it. And this functionality, for example, comes for free. Like, you don't have to say in Shiny that you have the ability to sort these things. You can just automatically do it. But one of the things we really want to do is actually be able to click any of these rows. And that is why we needed to wrap this into this render data table, because what now we're going to say is we're going to say the selection mode for this is going to be row. So now if we put this as a thing, we can now start selecting rows. We can now start selecting rows in this data frame. And this is something that we will then be able to capture in a minute in our server and actually do something with it. You can also change this to rows. So if you make it multiple, you can select multiple rows. One of the things that might be a bit sneaky in our Shiny, you can click multiple rows and then they will all highlight. In the Python version, it's different. You have to use Shift or Control to select multiple. So it's not just like clicking another one will select it as well. It's only by using Control or Shift that you will actually select multiple. And this only works if you have the rows, right? If you just have row, that means you can only select a single row at any point. Even if you try to use Control or Shift, that wouldn't work. Okay, let's now actually capture this. So what I want to do is when the user clicks any of these rows, I want to get that and I want to do something with it on the server to do something else somewhere in my app. So what we're going to do is we're going to add here a new element, and let's just create a simple text output. So we'll do UI dot output text. Whoops. There we go. And I'll call this one out. And now we're going to do something whenever they click any of these rows. I want to render something in this output text. So first of all, let's create this reactive environment. So we're going to define out. And here we're going to set the text that we want. So in this case, let me just keep it simple. I'm just going to return hi. We'll make this later something interactive. And now I'm going to add here my render.text. Okay, so now if I save my app, I should now get a text output that will show this. You can see it's all the way in the bottom of my screen here. This is because I'm so zoomed in to make it show that it looks nice on your screens. Normally it should come up way higher, but because I'm very zoomed in, it makes this table very large by default, and I'm not setting any specific heights because I don't want to confuse you with all of this sugar syntax. So, but you can see we have the output here now. Okay, instead of just displaying hi, let's now actually see, I want to get A, B, C if I select any of these rows. So we need to capture which row has been selected. In Shiny, in our Shiny, it's a bit trickier because it has this sort of a hack where you have to use the input and then underscore and then row selected. So the input object gets modified and you need to know how to do this. In Python, because it's object-oriented, it's a bit easier. You are just going to call a function on this table, or you're going to observe a function on this table object and really just get the results from it. So the way you do that is the table that we have. So this is table, and in here we can now have cell selection. So this means this is going to let us know which cells are selected. Once you know how this object is structured, we know we want to get the rows that are selected from this. This is all a little bit syntax, but it's once you know how this works, it's very easy. And at this point, we want to then get the first value that is being shown. So let's just make this 0. And now if we would return this instead, so instead of just this hi, If we run it now, what we hopefully should get, if I didn't make any errors, oh, I did. I forgot to say that we wanted to have the y value. You will still get an error in the beginning because see, you get an error, but as soon as I click something, I do get, well, I should get, let me see what I've done wrong here. What did I do? Oh, we want to get the y value, sorry, again. I forgot to actually select the value from the row. So we have to subset this. So what this is going to return is whether we have 1, 2, or 3. So if we look at this, let me take a step back. If we do this like this, I now should get, hopefully I'm done with the errors. Yeah, you can see I'm selecting row 0, row 1, or row 2. So this is what is being collected. Just as a reminder, Python is zero index based, and for us R people, that is sometimes very confusing. So if I'm selecting this first row, this is index 0, so I will get 0 back. Now, the rest of Python is also zero index based, so you don't need to shift anything, but just remember that if you're trying to debug things, that if you see 1, you're actually talking about the second row and not the first row. So instead of having 0, 1, 2, we actually want to get which value this is. So all we're going to do is now use some subsetting in pandas to get this. So we're going to say here, and this is just some panda syntax. We're going to say info ilog, and we want to get here, we want to only get the first of these values, and then we want to get the y column. So if we do this now, we will now see when we click it, we get A, B, or C. But as you might have noticed when I did it in the beginning, and I did have nothing selected, I got an error, tuple index is out of range. Why? Because this element is empty. So one of the things that you have to remember is, and that's up to you as the coder, is that it could be that if nothing is selected, this value becomes 0 or none or null, depending on what you're doing, and that might actually break your code. So there is this requirement function, it's the same as in R, where you can say only if the value is not null or any other requirement that you say, then only then proceed. So if I now say only if there is any selection, so in this case, require that this has at least a value in rows, and I do it now, now you will see that there should hopefully be no more error. So see, there is no more error at this case. And whenever I select something now, my code will be working again. So just as a quick recap on how the data table works. So all you need to do is put in a data table output. So not a table output, that's different. That's just a plain one. A data table, an output data frame, I'm sorry. So you put in an output data frame, then you create a function that is a render data frame, and in it you return any valid pandas or other library that is supported to create data frames. You wrap it into the data table object, and then you can set here, this is only one of the options. You have way more options in data table, but I'm showing you the one that's most useful for now. The row or the column, the row or the rows that you want to have. And then if you want to access whichever of these rows is being selected, you just call that object here. You ask for the cell selection. You say that you want rows, because again, you can also select other things. You can select individual cells, or there are other options available as well. Which of the index do you want? In this case, we only, if we have multiple, we only want to have one thing selected because it's a tuple. And then we use that to subset our data frame. So again, this is a bit of boilerplate code, but it is very, very simple to work with once you have an idea. And again, this gives a lot of powerful functionality, because oftentimes you want users to be able to say like, okay, give me some more details about this, and then you can render whatever analyses or data that you want here. You can also do it with multiple rows and then have people really interactively explore. So that's the part on using the data tables in Shiny. And the last part that I'm going to show is working with the plotly. And so Plotly is a very powerful library that is being used to create interactive images, or like interactive plots. So the default plotting libraries in Python, or the popular ones, are things like Matplotlib or Seaborn, but they're very similar to ggplot in the sense that when they create an image, they actually render a JPEG or a PNG image. So a static image, something like you would source into your www folder. These images are not interactive, it's just one image. So every time there is a update to be made, then the just I have a alarm going off here. I'm just going to quickly dismiss this. Okay. Okay, so every time that you have there we go. Sorry, I was distracted for a second for an alarm. So every time that you want to use an update to a normal, like in our ggplot or a matplotlib or a seaborn in Python, you will really get just an image back. And that can be very slow. It's also not really interactive. By a Plotly library, on the other hand, is a JavaScript-based framework where you can interactively zoom into a plot. You can select pieces. You can hover. These are all built-in functionalities, and then you can capture these signals and use them in R. And this because, in Python and in Shiny. And this is really powerful to really syntax or to subset specific things. So I made for you a little, because this is already more complex, but I just want to give you an overview. I already created the app here for you. Or I already have something created. So let me first go to you to show what you will need. So again, we'll create a basic app. So we'll need Shiny, we'll need pandas. We're going to work with the same type of UI that we were working with before. So from the previous example, so we'll still have a, we actually don't need this part at the moment. We'll still use the same data set, but instead now of going to render this as a table, we're going to render this as a bar chart. And so the UI now is slightly different because first of all, we have to load Plotly, and Plotly is not part of the core Shiny library. Data tables is, but Plotly isn't. And so I'm going to add the Plotly library in here. And so this is Plotly Express, and that is again, it has multiple APIs. Very important, this Express has nothing to do with Shiny Express. So I'm using Shiny Core here, but I'm using the Plotly Express library. That's just because it's a higher level API to the Plotly library. We'll see in a minute that we also might need another level of this API. But just in general, how people most of the time create Plotly plots is using plotly.express, and then they import this as a Plotly object. Unfortunately, I can't show you at this point in my editor how to create a basic Plotly plot without Shiny, because there is currently a bug that Positron breaks on the latest version of Plotly, and even the lower version that I'm using now only works in Shiny. So I will immediately show you the result in Shiny, but it shouldn't make any big of a difference. The other thing that we need to do, because Plotly is an extensive external library, we need to import. We need to create different UI and server objects. So for the UI, instead of doing the normal UI dot output, there is no Plotly in here. So what we're going to do instead is use a generic function called a render widget. And so there is another library called Shiny Widgets, which you have to install separately. So Shiny Widgets here has multiple functions, but we only need two. So we need to import a rendering function and I'm just going to replace this quicker. We only need to import a rendering function and a output function. So this output widget, that's what's going to go into the UI. So in this case, we can set our UI. Let's call this just simply Plotly. And then we can now create a server function. And here in this server, let me move this again outside of the server function. Here in the server function, we can add our new Plotly plot. So in this case, our Plotly plot is called just Plotly. So we'll do Plotly. And what we're going to return here is our Plotly plot. So I'll just quickly create this plot from the data set that we have. So we're just going to return a Plotly plot. And so in this case, it's the way it's created, it's Plotly bar plot. We want to use the info data frame. We want to just plot the x and the y variable as a plot. And then we again need to make this reactive. Again, we don't have this not built in, so we can't use the regular rendering functions, but we're going to use this render widget function. And this render widget function will be able to interact with the Plotly library. This is because there is a whole ecosystem of Jupyter widgets. It's a very extensive framework where many different people have created interactive widgets for the web. And there is a way for Python to interact with these, and Shiny has created a wrapper around this so that with almost every existing type of Python widget that there is available, Shiny can interact with them. And this is a very powerful feature because, again, the Python community is much larger than the Shiny one, than the R one, and there are many, many different types of Jupyter widgets that in future hopefully only will be even easier to just interact with. So we now should have all of the basic things to create our Shiny app. So if we run this now and we try to see what is happening. So I'll try to refresh. Okay, so let's load this Plotly plot. Okay, it's almost there. There it is. Okay, so finally we have our Plotly plots available. Took me a second. So now you can see this is a Plotly plot, this is a bar plot, and what I get for free from Plotly without having to implement all of this is if I hover over something, I already get some information. I can zoom into these plots and get some more details. And you can see all of these things. You also have things like save an image, download as an image. You can select specific parts. So you can pan around in the plot. So this is a very powerful way library that already provides you with a lot of functionality. But now, again, the same as with data table, we want to be able to interact with this. So what we want to do is say, if I click something, for example, one of these bars, I want to know which bar has been clicked. And again, that's something that we can do in Shiny by observing this Plotly interactivity. And so the way we're going to do that, and this is where things now become a bit hacky and more difficult, because this is not integrated in Shiny itself, so we have to dive into the Jupyter widgets. This is really some advanced coding I'm showing now, but I wanted to end, well, before we go into last exercises for people who want to do some more advanced things, we actually now need to import a separate section of the Plotly library, and that's the graph objects one. This is a more lower level library, and we need that to actually create these objects. So instead of just immediately returning our plots, what we're going to do, and I'll just show that in one go here, we're going to return a widget now. So we're going to create a new widget, and the way we do that is we just still generate our plot the way as we did before. So there is no difference. But now we will explicitly turn this into a widget. And why do we do that? That is because we can actually now access this element here and add a click function to it. So this is again is some boilerplate code. We say we want to work with the first level of data, so with the first axis, so which is only this, because there's only one level of data in this plot anyway. And now we want to add a function that says on click, not on lick, on click. And here we can now provide a function what it should do whenever it is. So we have to create a new function here, which is a plotly click. We'll call it plotly click. You can call it whatever you want. And we need to define now what this function is going to do. So this plotly click function, again, this is all boilerplate code, has some basic parameters that you will be able to access, which are the trace, the points, and the selector. This is not a reactive function. This is just a function that will be served in here. And now in here, we can actually access specific elements. So for example, we can show which of these elements is being clicked. So hopefully if I don't have everything right, and I'm doing this, so Shiny is going to create a plotly plot. We're going to capture this widget. We're going to add a click function. This is going to link Shiny to this actual plot. And as soon as we then click, we should get hopefully some information in the terminal. Let's see. I probably made some small mistake here where you can't see it. Points. Okay, so now normally if you would click it, again, but I'll make it a bit more. I'll use my bigger version of the app. So if I would take the whole thing, I'll walk you through the code in a second. So in this case, all I've done is created a little bit additional Shiny. So I've created an output one that will now show in the console what is being selected. So now if I click, you see you click bar 1, 2, and 3. So the way I did it was the same as before. I create my Shiny, I create my widget first by creating the plotly plot. I explicitly make it into a widget. I set this plotly click function. And in this function, I am going to observe the points, and I want to know which point has been clicked. And I'm going to assign this to a reactive variable in Shiny, and then I can do something else with it anywhere else, because as soon as this variable changes, and because it's 0 index based, I now set +1, because it would be weird if you say you clicked bar 0, because it's 0 index based, but that's just for making it prettier. But again, this is relatively complicated. This is a lot of boilerplate code, but once you figure it out, you can actually start adding all different types of functions. You can do click, hover, zoom, and all of the things that are available by default in Plotly, you can capture in Shiny. So for the last 20 minutes, well, for 20 minutes now, before we start wrapping up, I would like you to have a go at it. I think the plotly plot might be for many people too confusing a bit at this point or too advanced, but if you have a lot of experience, go for it, because that's why I'm putting this in. But for the other people, exercise 1 is really focused on creating the data table example, and that's the one I think it's really useful. So let's take 20 minutes, and then we'll come back for the final wrap up of this workshop. So, and I will obviously start answering questions again in the chat. Okay, so again, feel free to mute me and come back in 20 minutes. Good. So there's a question of if I could push my live coding scripts to the repo. Yes, I will give you all of the examples in the end. I'll upload them as well. Same with when I also changed hopefully the data set that was missing. So another question is, if there is no equivalent to data table in Python, does it mean that they implemented more options in the core Shiny rendering data tables?
Yes, I think they did. Again, there is actually, I think, a data tables. There is a data tables package library in Python, so I'm sure you can interact with it as well. But this data table in Python has a bit more functionality. Again, I think I learned from the Shiny one. For example, one of the things, and I'm not showing that because it's too advanced, but in Shiny, in R, you have this concept of proxies, where you can use a proxy object to actually update a data table or a plotly object, but without having to render the whole thing, because it's an interactive element. You can change specific components by using the proxy. But for example, in Python, that's all built in. You can do that from within the Shiny framework. Again, it's not because Shiny necessarily has extended it, it's just because these Jupyter widgets have been built in such a way that or of these widgets, I keep saying Jupyter widgets, but these widgets have been built in such a way that they already have all of this functionality built in. So Shiny just needs to be able to give you access to them, and then you just modify these widgets as is. Let's see, are there any other questions for now? No, okay. So again, please feel free to work on especially exercise 1 here, because this is a relatively simple but very good example of showing you how you can use the data tables. In this case, I want you to create a task manager, as a very simple task manager app where you can use the data tables to your functionality. And in this case, the Shiny Live link should work because there are no external datasets available. Oh, there's another question. So since the whole code is built in Python, when deployed over a cloud platform, will the logging work similar to how it works in Python? Because if you deploy RShiny on cloud using a custom Docker file, you need to redirect the log script to std out. It's a very good question. This is already very deep into the framework. I have not that much experience with the deployment of the apps yet in the cloud platform at this point. And again, it's one of the strengths, I think, of Shiny, is that I'm using mostly Posit Connect implemented by my university where I work. And they allow me to just push everything to Posit Connect, and they have built-in logging already. So I am not entirely sure if this is all going to be, or this is all implemented yet. But I think this is also a great opportunity because it's all still very new. If you do have suggestions or features or things that you find different, before they really get solidified, maybe you can open some GitHub issues or on the community forum, open up a topic and try to see if you can rally people to make that happen if it's not available yet. But again, I have not that much experience with deployment because I've mostly used Posit Connect for my deployment and just its built-in Everlog. Another question is, could I create a widget for Shiny for Python app using something from Dash? An editable data table in Shiny for Python does not let me copy paste entire columns. So yes, Dash is is a bit of, it's a different library, but you will see like for Plotly, I think as well, there is also a Dash implementation. And again, if you can create your own widgets, if you do have the knowledge on how to create your own widgets in Python, especially if using the things like the Jupyter framework, you could have Shiny interact with them, because all you have to be able to do is, like with it here, is if you have these on-click functions, like this is not Shiny, this is at this point the widgets itself, you can just add any arbitrary function which will be run on click, and then you can add some Shiny functionality on top of that. So again, this is a difference with a bit of our community. Like the Python community is much more, has a lot more ways of crafting different things, and some of the frameworks are made bigger and robust. Robust not necessarily, but at least way bigger. So yeah, this whole ecosystem of Jupyter widgets, if you can create your own widgets, you can build it into. And I think even in the documentation on Posit, they have a whole section on how to create your own widgets. So it's a long time since I explored it, but I recommend you go to it and you just look at the how to create your own widget. But again, this requires extensive knowledge of obviously how to use JavaScript and CSS and like, building this whole thing and then connecting it to Shiny. Another question is back to modules. R6 classes are a great way to pass data between modules. Is there an equivalent functionality in Python Shiny? I think again, I haven't worked that much. I have worked with modules mostly for like teaching in my courses, but the way modules are set up is very, very similar to R. But obviously, Python has a whole different way because it's object-oriented, how it works with things like classes. So I'm not entirely sure if the R6 classes, the way you do it in R is immediately translatable to Python. Again, I have quite some experience with Python, but I'm mostly myself also by training an R coder. So I wouldn't be able to give you a definitive answer on that. But again, I think because of the object-oriented way that Python is created and the fact that you have this way different, and I think it's an easier system, like the way you define classes in an object-oriented language, I think it would be possible to transfer them. But again, don't quote me on that for now because I don't have that deep dive into the modules. But modules is definitely possible. I thought of putting that as an additional option here, but I think these four were already more than enough to get you all through. So. Feel free also to ask me any other questions about the previous exercises, right? Because after this, in about 10, 12 minutes, we're going to wrap up anyway. So then I want to, and then can answer any type of question, but feel free to already throw them at me now if you want. But please try to do the exercise as well, because this is, I think, one of them that it takes quite some boilerplate code, but once you know how to do it, it's very useful and powerful, and honestly, not that hard to do. There's at this point not many people asking me questions, so I'm hoping that you're all doing the exercises. But I can also quickly. There we go. There is another question. Somebody is showing me just a potential bug that they have. It's very hard to debug it based on the information that I have now. But again, actually, the error that you do get is expect the data frame but got a reactive value. That oftentimes means that you are like, let's show that here. Again, if you want to access a reactive value, you have to use the parentheses, because if you don't use them, you will actually return the Shiny object instead of evaluating it. So again, using in Shiny, in Python at least, all reactive values, if you access them, would have to be used with this. But the also, by the way, and I think it's one of the things I might have skipped over, if you create a reactive value, a reactive variable, you need to get, you need to set them with these specific set functions. So you can't just use this, because in R Shiny, you can just wrap this inside of the parentheses, and then it will update. In Python, you have to explicitly use the .set function to do it. There is also the equivalent get, but actually get is not really required. You can just use it without the get, but for setting, you need to do that. But if you get this type of error where it says, I'm getting a reactive value and I expected something else, that might just be because you either didn't use something like this or you were not using the parentheses. Oh, I'm happy I answered your question on the without that much of the context. So again, all of these exercises are still available. The repo is also publicly available, so feel free to share this with other people. And if you have other ideas on how to improve this, you can always share that with me as well. But the exercises, solutions are all available in this last section of the thing. And then also because of the Shiny Live links, you can just share the Shiny Live link with anybody and then create, they can immediately start trying the exercise as well. And you can create your own Shiny Live apps very quickly as well, right? In this editor, you can just save the results of any app that you made. And this means that people do not have to install anything. The downside is that if you use Shiny Live, that obviously it's all in the browser. You cannot store anything externally unless you would start creating a different API, or like you would start storing things remotely. And also in Shiny Live, all of your source code is exposed, because obviously if it's all running in the browser, that means everything has to be sent to the browser. Whereas in regular Shiny, if you just use a regular deployment, your source code or your app code is on the server, which is not immediately accessible. Only the assets, like what is in the static assets folder, or the actual pieces of information that you send to the user interface are available for the client to see. So the Shiny Live is very good for something like this. I think for teaching, for demoing. Also, by the way, all of the examples that you see on the Posit website are all done in Shiny Live. So whenever you see that sort of hexagonal grid appearing, that is actually a mini Shiny Live app all embedded in the website, because since it is a self-contained piece, you can easily add a Shiny Live to a static website even, because it's all being run in the browser anyway. So again, I think for tutorialing, for demoing, for quickly sharing something, Shiny Live is great, but I encourage you to set up Positron or VS Code if you really want to start going with this in a bit more detail. I think we have about like 5-6 minutes left before we're going to wrap up. Again, you have quite a few other exercises that you can work on as well. And if you have any questions from the previous exercises, feel free to just throw them in the chat for me now, and then I will be able to answer them for you. I'm also going to scroll up and see if there is any questions that I might have missed during this whole session, because we're reaching the end of 3 hours and I might not have been able to go over everything. Oh, there is a question, where do you go to get help for functions in Shiny Python? So again, it depends a little bit on what you are using. If you are using Positron, because Positron is built the same way as, well, it has some of its inspiration from our studio, you do have this help tab here. So you can do the, if you would pull up documentation, you can see it in here, but Posit also has the way that like you can click, if you write any functions, you could click and go to the, so for example, if I do here, UI.input action button, with the hover, you already can see lots of these documentation appearing for you. So it oftentimes is just shown inside of the anyway. But then the one that I mostly recommend using, that I find personally the most helpful, let me see here. Yep. So if you go to the actual website for, again, the Shiny for Python, you will get the references, so the Shiny Express and the Shiny Core. Again, I mostly use the Shiny Core, and here you will have literally all of the different things that you have, all of the inputs, the outputs, the reactives. They have actually a pretty good search function as well, so if you just want to find something, that's great. But if you, for example, want to learn more about how does the action button here exactly work, you get the same type of documentation as in you would get in R. But the nice part, again, and here you can see, you recognize it, this is actually just a Shiny Live app that's embedded in this web page. So you can immediately look at the examples. And the nice part is it's not just being rendered for you, you can actually edit this code and run it inside the browser. So if there is a example that they are showing you and you want to figure out how could I change this, or how can I make it change to this, for example, if I say here, I just want to make a name with a small m, I can re-render this and it will actually update itself inside of the app here as well. So that's the really nice part about this Shiny Live framework. And Shiny Live is also available for R, by the way. I don't know if I mentioned that, but if you go, so you see here Shiny Live Python, but if I make this Shiny Live R, I now go into the exact same thing, but now for R. So obviously that's not what my workshop is about, but if at any point you need to make some tutorials or have people very quickly get started with R Shiny, this is the exact same thing, but then for R. And I think that's a very useful way of using the resources without having to help people set up. Because I think if this workshop had been with me trying to make you set up all of this in Positron or VS Code, maybe only a quarter of you would actually be able to have caught up by the time we ended this workshop, because it can be a pain to set up all of these environments. So really a shout out to the people at Posit for creating this Shiny Live thing here. So some more questions coming in. I've already done something amazing here with Shiny for Python. Yeah, so yeah, I indeed, it's very, I'm very excited that people have actually in such large numbers joined this workshop. And again, I'll go a little bit over it in a minute when everybody comes back from doing their exercises. But the GitHub repo, again, is available for you at any time. And yeah, I did spend a very long time creating this, but I also think that the way to actually make the transition is by just doing it and seeing how relatively easy it is, because you all have the knowledge of R Shiny already, and that is the biggest thing to do. So I hope that that I can do this workshop more often and actually keep building on this, and hopefully convince more people that, as a skill, learning Shiny is not something that's just restricted to R, but you can do it in both R and Python. And I think especially with people who work with collaborators or in other types of industry or research, where some might be using R, some might be using Python, there is a big overlap on how you can just transfer. There is a question, is the repo all finished? Well, yes, I'm going to start wrapping up in 30 seconds here when my timer is on, but you have gone at this point through all of the exercises. So yeah, I just have a few more things to say about the comparison between R and Shiny and what the future potentially might hold. But based on the exercises, that was these four modules now were the ones that I had prepared. Is there a user group for Shiny Python and Shiny devs that you all use? Well, I actually really like to use the the R community forum, because it's actually now a Posit forum. I'm also a moderator on there, by the way, so you might come across me sometimes on the forum. And that is a great way of asking R or Shiny questions. A very nice community, both in Python and in R. And I find it way more working as a group together with people versus something like Stack Overflow. So our community forum is a very much recommend it. If you have, I'll see if I can share it later. But I just first want to start wrapping up. So yeah, I'll see. There it is. Okay, I found the link. It's been a while since I. So this is the Posit community forum, and on here you have. It's mostly still. There's still a lot of them in R, but they do also have now Python community that they are building, because again, Posit has this big push to trying to make data science not either R or Python, but combined together. Okay, so I will start wrapping up in the last 10 minutes here. So I think we have covered a lot in this. I just want to give you a very quick summary. So you have learned now how to create very quickly a UI, knowing that the way in the core framework in Python Shiny that UIs are built is near identical to Shiny. So I'm certain that many of you will be very quickly adopt this to build UIs. Then the reactivity, again, the concept of reactivity is highly, highly similar to the Python to R. Like it's identical, the reasoning behind it. The only big difference is learning how to work with these decorators. But again, it looks a bit alien in the beginning, these decorators, but once you understand what they do, I think they're a very elegant way of very quickly creating these reactive environments from basic functions. And honestly, they might be even a bit nicer organized. We quickly talked about the express syntax as well. So again, this is an alternative way in how you can write Shiny code, and express is really, in my opinion, at this point, mostly used for prototyping or quickly making part of a bigger script interactive for some exploratory analysis, or if you just want to say, if you prefer using this sort of framework, but I think if you go really big with your app or in full production, it might be nicer to switch to the core framework. But on the other hand, the way these frameworks work in the backend is building upon the same functionality. And then finally, we looked into Plotly and data tables. So how can we actually interact with some additional either external libraries or the data tables library inside, where we can really make interactive tables and plots, one of the really powerful features of Shiny, and use them in Python as well. And a little bit exploration of how we can actually access all of these existing widgets. Before we wrap up, I have a few things that I want to say that I haven't really covered yet. There are quite a few other things that we can do in R that we can also do in Python Shiny, but I just didn't have the time to cover, or they are just small things. For example, inserting custom CSS and JavaScript. This is something really powerful that you can do. So you don't have to be restricted to the layout, to the UI or the functionality or the layout or the markup being provided by Shiny. Obviously, the whole point of Shiny is to simplify that, but you can inject your own CSS and JavaScript, and it's identical a bit to how you do it with R. So the same, these files would go in the static assets folder. You just source them in. The boilerplate code is provided online, and then you can just create your own CSS or JavaScript functionality to really make your app look more beautiful or more interactive. You also have things like, for example, reactive polls. That's also something I like to use. That's also available in both R and Python. We already talked about modules because people had questions about it. The modules is a very powerful thing, especially because if you're creating bigger apps, so you want to reuse parts of the code, they are both available in the core and in the syntax, in the core and the Express framework. But again, this is something that not actually many people use in a daily, on a daily basis when creating Shiny apps. So that's why I didn't cover it. And there are lots of other smaller little functions that you can do. And there are a few things that are not available at this point in Python that I found that are available in R, but they are very minor, and I don't think that they're important. But for example, in Shiny for R, you can actually save a Shiny app as a function. So you can just save a Shiny app as a function, you can put in the package, and then when you run the function, you can immediately spin up that Shiny app. So it's all wrapped into this function. I've tried this multiple times in Python. It is not possible. It creates these async type of errors. There is also no mention of this on the documentation, so I think it's just not implemented. But honestly, the only time this is being used is sometimes libraries will implement a mini Shiny app inside of a function to make something more easy, but you can just wrap it anyways as a package and then use it like that. So it's not that it really hinders the distribution. Also, as I mentioned, the ShinyJS package is very powerful if you want to do some more customized JavaScript without having to write everything from scratch. I really hope that maybe somebody will create a similar library for Python, or maybe it's already there, but I haven't found it yet. So that's something also that's not available yet. So at this point, you still have to manually inject CSS or JavaScript. But for the rest, the Python framework is very solid. It is. I hope the adoption will be will be really skyrocketing now, and especially since many of you now have had some initial experience, I hope you can be the drivers as well to show to people like how powerful Shiny is and how easy you can just create both of them. I think that's almost all I want to say. I'm just going to quickly check if there are any other questions in the chat. I see that somebody said about the decorators. So yeah, again, decorators is something that I think Shiny is a perfect way to learn about decorators because they were very abstract to me. And once you understand how elegant they are, although they look a bit alien to us R people, they are a very nice way of creating functions. And then I see somebody says, do you have any preference for project managers like poetry? So I think I mentioned this a bit earlier as well. I like to use UV, so Astral UV, for managing my Python environments and projects. Or I use the built-in virtual environment as well. But in my case, UV is the one that I prefer to use. But again, in Python, there is a lot. I don't want to make statements that potentially have way more value, like discussion within the community. I know we are here in a mostly R community, but I don't have specific recommendations. I just think that Python is a bit more finicky sometimes to set up or to make reproducible. But on the other hand, they have many different libraries, so that's more personal preference. So yeah, I would really like to invite every one of you to give me feedback on this. So please, you can, as is shown in the main part of the repo. So let me show the main README file. If you scroll down to the very bottom, you will see my email address. So you can always shoot me an email if you have any other questions. I also have my LinkedIn available if you want to follow up. I'm also looking for new opportunities for my career as well. So if there are any opportunities where you think I can help out, I'm very happy to hear those things as well. But for all the rest, I would say keep trying the exercises, try to spread the word about Python Shiny. And yeah, you can share this repo with anybody else. And I'm very honored that you all spend 3 hours with me. My voice is a bit hoarse now, but I'm very excited that it mostly went well without any major hiccups, apart from me dropping off once. So thank you very much, everybody. And I really encourage you to explore the whole rest of the Shiny conference because there's a lot more fun stuff to come. So thank you very much. I will stay on for a couple more minutes until they kick me out of here. But yeah, it was a pleasure to be with you.